So in this video we will look at the number of moles of cobalt that are found in 6 billion atoms of cobalt. So always start with what you're given. Now the units here are atoms, 6 billion cobalt atoms. Anytime you see atoms, that word, or ions, that word, or the word molecules, you have to think of Avogadro's number. So how many moles are involved or are within 6 billion atoms of cobalt? So start with what you're given, which is 6 billion cobalt atoms. So you're going to start with what you're given, which in this particular problem we have 6 billion atoms of cobalt, and we want to convert that to moles of cobalt. So 6 billion is 6 times 10 to the 9 atoms, okay, of cobalt, times, this is where we're going to use Avogadro's number, 1 mole of cobalt is 6.022 times 10 to the 23 atoms of cobalt. So the atoms of cobalt and the atoms of cobalt will cancel out. So 6 billion, or 6 times 10 to the 9, divided by Avogadro's number, which is 6.022 times 10 to the 23rd, will give you the answer. So doing this on our calculator, so the way you'll do this on your calculator is 6 times, now I don't see an EXP button on my calculator on this version, so it's going to be 6 times 10 to the power of 9. There you see the 6 followed by the 9 zeros, divided by Avogadro's number, shown here, 6.022 times 10 to the 23rd. So divided by 6.022, I put the parentheses in there, times 10 to this little caret here, which is the exponent mark, 10 to the 23rd. I'll close those parentheses and I'll get my answer, which is about 9.96 times 10 to the minus 15. So 9.96 times 10 to the minus 15, that's a very small number, moles of cobalt are encased or is equivalent to 6 billion atoms of cobalt. So in this particular problem here, we're given, like before, we're given this many atoms of lead, and we want to figure out grams. Okay, previously we were figuring out number of moles. Here we want to figure out the grams. So there's an additional step here. Let's go ahead and convert that to moles of lead, because 1 mole is Avogadro's number of atoms, and it's asking for grams. So I'm looking this up in the periodic table. This is about 207.2 grams of lead. So using this relationship with Avogadro's number, the atoms of lead cancel. The moles of lead cancel. Again, on our calculator, it's going to be 1 times 10, that little caret for exponent 12. So that's 1 followed by 12 zeros, times 207.2, times 207.2, divided by Avogadro's number. So I'm going to put parentheses anytime I deal with exponents. 6.0 divided by parentheses 6.022 times 10, that little caret exponent 23, close the parentheses, and 3.44 times 10 to the minus 10 grams is the same as 1 times 10 to the 12 atoms. Okay. So the purpose of this video is to really hammer home this idea of Avogadro's number. Okay, atoms, also molecules. So 1 mole of glucose will have Avogadro's number, molecules of glucose. Let's say we're talking about the ionic compound sodium chloride. 1 mole of sodium ion will have Avogadro's number, sodium ion. So atoms, molecules, and ions.